Okay, today we are focused on mean absolute deviation. This is part one. It's telling us that one way to describe the variability or how spread out a set of data is by calculating or using the mean absolute deviation. And this is the average distance that a data point is in a set of data are from the mean of the actual data. Okay, so it's asking you how or what does deviation or deviate mean and how can it help you remember the definition of mean absolute deviation. That just means, again, how far apart a number is from the actual average or mean of the data that you start out with. I made it into simple steps, but here are the steps. One says find the mean of the data. That means you're going to add all the numbers up and divide by how many there are. Number two says find the distances from each data point in the mean. So whatever you get as your average here, you're going to subtract the number that you have from the mean that you calculated, and then you're going to get the absolute value of those distances. That's like step 2.5. And then you're going to find the mean of the distances. So right here, before you move on to step 3, and I'll show you what that means, you're going to find the absolute value of those distances and then find the mean of all of the values from step 2.5. But let's calculate a little bit. Down here you have an example. 61, 68, 63, 67, 70, 62, and 64. It says a police officer recorded the speeds shown at the right for the last 7 drivers that passed on the highway. So we know that we have 7 numbers right here. And our first step is going to be to find the mean of that data set, okay? So we are going to add all of those numbers up and divide by 7. So take your time, take your calculator, add the numbers up so that we can divide by 7. And I'm going to add over here because this is something that Miss Maxine was not prepared to do. Hopefully this is going faster for you than it is for me. I got 455. I think we're going to divide that number by 7. Again, I hope this is going way faster for you than it is for me. Yes, 455 is what I got. So I'm going to take the number and I'm going to divide by 7. And I'm going to get 65 as the answer. So that number is my distance, or my mean, sorry. And then I'm going to come over here and I'm going to subtract 65 from each one of the original numbers that we started with. So 61 minus 65, 68, 63, 67, 70, 62, and 64. All of those numbers minus 65, and I'm going to get positive and negative numbers. This is where that absolute value part comes from. We found the mean. Now we have to find the absolute part. Find the absolute value of each number. This is going to give you your distance. I have 4, 3, 2, 2, 5, 3, and 1. You just take the positive values. We cannot have a negative distance. Think about it that way. You can't take negative steps backwards, or you can't, when you walk backwards, you're still taking positive steps, if that makes sense. Now we're going to take these numbers and we're going to find the average of the distances, or this right here, or the mean absolute deviation to the nearest tenth. So I'm going to take these pink values, I'm going to add them all up and divide by 7 again to find the mean absolute deviation. So let's add them up. We have 4, 3, 2, 2, plus 2, plus 2, plus 5, plus 3, plus 1. This is all of that divided by 7. I believe that is 20. Sorry, 7, 8, 9, 10, 11. This gives me 16, 17, 18, 19, 20. So 20 divided by 7. And I got 2.85. Or if I'm rounding to the nearest tenth, like it asked me to, 2.9 is my answer. So it says explain what mean absolute deviation represents in the situation. This right here just means that each driver was 2.9 miles away from the average speed, okay? And this is the piece that I'm not worried about, but to make it make sense for us, each driver was 2.9 miles away from the average speed of 65 that we calculated in step 1. And then we're going to move on to the back of this paper because yes, there is a back. This first situation says find the mean of the data. The ages of several patients in a waiting room at a doctor's office are shown in the list at the right. You got 4 plus 3 plus 58 plus 11 plus 28 plus 64, and you're going to divide all of those numbers by 6. When you do that, you should get a total of 33, I hope. Then you're going to go to the side and you're going to subtract each of those numbers from 33. Use your calculator. There is no need to be a math whiz. You can use your calculator. You should get negative 29, 0, 25, 22, 5, and 31 for each of those. Change them all to positive values before you move on to the next step. The only one that you have to change is that negative 22 right there, and that negative 29. So we're going to take all of these values and we're going to put them here. I got 29, 0, 0 does count. It's still a number. 25, 22, 5, and 31. And this is me just changing them to positive values before I add them all up again and divide again so that we can find our distance from the data. So 29 plus 0 plus 25 plus 22 plus 5 plus 31. All of that should give you 112. Divide by 6 because you still have 6 numbers. 0 does count as a part of your data. And round it to the nearest tenth. Miss Maxon got 18.7. Let me know what that means or explain what the mean absolute deviation represents in this situation. Take a beat and then we're going to move on to the last part. It says the numbers at the right represent the number of minutes that it took Diana to get to work each day last week. So she had 21 minutes, 26, 47, 44, and 22. And she worked 5 days last week. Once you calculate all of that, it should be 32. Take all those numbers, add them together, divide by 5. It should get you to 32. And then you're going to subtract each one of those numbers, or 32 from each one of those numbers. Negative 11, negative 6, 15, that's what, 8, 9, 12, and negative 10. Take all of those numbers and change it to a positive value before you find the mean again. We're going to have 11, 6, 15, 12, and instead of negative 10, a positive 10. Change all of these numbers to positive before you move on to the next step. Add them all together and divide by 5 again, because no matter what you do, you should still have 5 numbers, okay? Adding this all up, we get 54. Divide by 5. We should get 10.8. And it says, what does the mean absolute deviation represent in this situation? And you are going to describe what it takes, or what it means, and move on to the next piece. For the next one, Dominic sent the following number of text messages each day over the last week. Find the mean absolute deviation to the nearest tenth and explain what it means or sorry, what it represents in the situation. Miss Maxon just wants you to find the mean of all of this data and then tell me what the mean absolute deviation of that data is. Okay, and then this last one is talking about Mrs. Pitchford using the mean to calculate test scores, and it wants to know, do you agree with her, with Preston's conclusion about the test scores? And no, we do not agree with Preston. Matt tells us the spread of the data, not the actual data itself, so it can't tell us what the test scores were or how well or poor his class did. Next video will be an example of how you're going to do your worksheet, or work your practice out. This is the practice, so grab it and then follow me to the next video.